What you're probably pointing out is that we still have some work to do in completely explaining the entire value proposition. One of the advantages of the software-defined idea is you can pick hardware to match the scale and performance requirement that your particular workload has. So if you ask the question, what is the performance of software-defined storage, the literal answer is, well, it depends. What do you want it to be? If I instantiate it on high-performing servers with a lot of memory for cache and back-end flash, I can have a absolutely roaring software-defined instance. If I deploy it on a light server with a slow disk behind, then I'll have maybe a slow, cheap instance. And those decisions about which of those options I'm trying to create is part of the management process and planning process that customers have to go through. What service am I trying to provide? What performance requirements does it need to have? One attraction of software-defined storage, since performance can be whatever I need it to be, where I have performance-critical need, where current infrastructure is not meeting the need and I need to modernize, that can become an on-ramp for software-defined. So I know I need something new. In the course of doing something new, not only have better performance, which I can achieve with software-defined storage, but better flexibility, better management, better long-term result in my overall infrastructure. One of the design characteristics of XIV since its inception has been the notion of a homogeneous cluster. So basically you create a cluster and you randomly distribute data from exported LUNs across all the spindles or SSDs within that cluster. Now, separately, there's the question of, but what if I've got different applications with different performance requirements or different capacity and scale requirements? What do I do with that? The approach that we're following with Spectrum Accelerate is to be able to allow customers to create different pools of Accelerate instances. So I create a fast pool, a slow, inexpensive pool, and through policy I can assign workload to the appropriate pool. That's a different notion than tiering, which implies that the storage will sort of on the fly figure out the needs of a particular application set and move data up and down within tiers. We've actually had tiering in place for quite a long time now in the enterprise storage products, but in a sense what we're seeing here is sort of a style question. The whole idea of cloud and software-defined seems to benefit the most where storage and other infrastructure products are in effect the simplest. And I raise up in the stack the intelligence of what needs to be done, put that intelligence closest to the notion of business policy or user selection or what an individual user or tenant is willing to pay, which is a very high-level notion, instead of trying to drive that all the way down to artifacts of intelligent movement up and down a tier within a disk array. So I raise the question all the way up to the very top, I settle what the need needs to be, and then I correctly steer the data to the simple implementation of a high-performing environment or a slow, cheap environment.